Assalamualaikum. Our topic today is groundwater, aqueducts, and water pipes. Groundwater. Hydrosphere includes water in and on Earth's crust. 97% contained in oceans. 90% of the fresh water is in form of polar ice caps and glacier. Ultimate source of all water on land is on the ocean. Infiltration process where the water enters the ground becomes groundwater. Groundwater. Underground water that fill almost all pores in rock and sediments. Pores supplement about one-fifth of freshwater needs. Groundwater system. Zones of saturation. Layer of ground where all the pores are filled with water. Water table. Upper surface of zone of depth varies depending on local condition. Zone of aeration lies between water table, earth and surface. Rock properties that affect movement and storage. Flows downhill in direction of slope of water table due to gravity. Rate depends on. This is the example of groundwater flow direction. Porosity. Percentage of open spaces in a given volume of rock or sediments. Sorting. Type pack. Particles packed together. This is the pores. The example of the picture. 3. Permeability. How freely water passes through open space in rock or sediments. Permeability. How freely water passes through the open space in rock or sediments. This is the example of clay connected pores with rock permeability. Aquifer. Layer of a permeable rock that has connecting pores and transmits water freely. This is the example of the aquifer of the picture. Rock, fine aquifer, clay, the water. Topography and water table. Water table is found at different depths below ground surface. Depth depends on topography of land, permeability of rock, amount of rainfall. Prolonged rainfall, drought periods. Rich water table. Secondary water table formed by a layer of impermeable rock above the main water table. So as you can see in the picture, water table and the spring and the river. Erosion and deposition. Usually slightly acidic and will attack and dissolve a carbonated rocks such as limestone. Cave. Natural underground opening with connection to Earth's surface. Caverns. Large cave often containing many smaller connecting chambers. Sinkholes. Circular depression caused when roof of cavern collapses. Karst topography region where the effects of chemical weathering due to groundwater are clearly visible. Hard water contains relatively large amounts of dissolved minerals. 7. Speleothems. All minerals deposits formed in caves by the action of water. Veins. Area of igneous rock where hot groundwater collects metallic ions in solution and then deposits them in metallic ores. Natural bridge. Arc of rock. This is the example of the natural bridge. Groundwater system. Springs. Ordinary springs. Natural flow of groundwater to the earth's surface. Artesian spring. This is the example of in the picture. As you can see, natural flow of water to Earth's surface from an artesian formation. This is the cycle of the hot springs. Hot groundwater that rises to surface before cooling. Geysers. Hot springs that erupt periodically. Travertine. Form of calcite that is deposited in terraces around the mouth of hot spring. Here is the example of the hot springs in the Baguio of that. Mud pots. Withered rock around hot springs that mixes with hot water to form liquid clay that bubbles at surface. Threats to water supply. First, overuse. Supplies can be depleted if water is pumped out at a rate greater than recharge rate. Subsidence. Sinking of land due to excessive withdrawal of water. And the last one is pollution. This is the picture of the pictures of aqueducts photos. See, as you can see here, this one and this one. Okay, how is an aqueduct constructed? The first story composed of 6 arches. The second story consists of 10 arches, and the third story carries the water with 35 arches. Arches. Especially the arches constructed in the Pondo Guard were built around wooden frames. The frames were removed upon completion. An arch was constructed from each end up to the centerpiece, known as the keystone. The keystone exerts a force on the adjacent stones, so that these one stones at the top of held the entire arch together. Thus, it is the key to the structure. The Romans transported water from far away to cities via aqueducts. Cities had plumbing, providing private water for the rich and public, but poor neighborhoods share a public water set. This is the example, and this is the map of Marcia. How does an aqueduct work? Water is a heavy stuff. It weighs 8.34 pounds per gallon. The Romans needed a structure strong enough to hold all the water to move it from the mountains into the city. The water was transported in concrete tunnels. The tunnels were underground if possible. Sometimes the tunnel had to go above ground. So this is the picture. This is the tunnels, and you can see the water flowed in the tube top of the aqueduct called the water channel. The arches supported the water channel. This is the aqueduct channel arch, so that's one is supported. The channel was lined with the concrete. The Romans invented concrete. This is the example of the concrete. How did it work? Gravity made the water flow. Roman engineers had to construct the aqueduct so the water would flow. comparing Rome to modern. So you can see this Aqueduct Bridge. So next, water pipe and connections. This is the introduction of the a water pipe is any pipe or tube designed to transport treated drinking water, potable water to consumers' buildings. They differ according to sizes. First, large diameter main pipes which supply entire towns. Second, smaller branch lines that supply a street or group of buildings. And third is small diameter pipes located within any individual buildings. Materials used for construction of pipes. Pipes come in several types and sizes. They can be divided into three main categories: metallic pipes, cement pipes, and plastic pipes. Metallic pipes include steel pipes, galvanized iron pipes, and cast iron pipes. So, cement pipes include concrete cement pipes and asbestos cement pipes. Plastic pipes include plasticized like polyvinyl chloride PVC pipes. These the different types of cast iron pipes, steel pipes, galvanized iron pipes, copper pipes, plastic or polyethylene or it's called PVC pipes, asbestos cement pipes, and concrete pipes, and last one is polypropylene pipes. Galvanized iron pipes. This type of pipe is used for water supply work inside the building. These pipes are root steel pipes provide with the zinc coating. Application areas, water and storage, like firefighting installation, and the last one's plumbing system. Galvanized iron pipes. This is the advantage and disadvantage. First, advantage. Low installation and maintenance cost. Long life. Toughness, anti-rust pipe. Useful for large construction projects. Durable and large diameter. So the disadvantages of these iron pipes is heavy to handle, develops blockages, and difficult to repair. Steel pipe. Steel pipes are comparatively expensive, but they are strongest and most durable of all water supply pipes. And the next is galvanized pipe. Less frequent use now as rust can build up inside smaller diameter pipes. Cast iron pipe. Cast iron pipes are quite stable and well suited for high water pressure. However, cast iron pipes are heavy, which makes them unsuitable for inaccessible place due to transportation problems. So, and next, the concrete pipes. Concrete cement pipes are expensive but non-corrosive by nature. Their advantage is that they are extremely strong and durable. And the last one is PVC pipe. So this is the example of the PVC we used to use at our home, like color blue. The PVC full name is polyvinyl chloride, used for hot and cold potable water as well with sewage application. This example of table of sizes of pipes. Size of cast iron pipe is in inches diameter, the inside of diameter and the outside of diameter of barrel. And the size of steel pipe. So as you can see, the external and the internal diameter and the pipe size. Size of galvanized pipe. So as you can see, this is the size on the left side, and the middle one is the external D, and then the internal D. Using unit in inches. Size of PVC pipe, the color blue, like you can see, the normal size F millimeter. The unit we use is millimeter, and the diameter is inside and outside. So I Along pong Abdul Majid So thank you.